This is just a quick note to say that if we do use the integral test, and through the integral test our series converges, we still don't know what the series value is, or what the sum of the series is. All we know is that sum is finite. So for example, let's think about one of our friends. Think about the following series, from n equals 1 to infinity, 1 over n squared. Now for us, this is a p series with p equals 2. And since p is equal to 2, which is greater than 1, which was the condition for convergence, our series converges. Okay, so we know that this series converges. Now, a famous mathematician named Euler showed back in his day that this series from n equals 1 to infinity of 1 over n squared, the final sum of this series, meaning that this infinite sum or infinite summation of infinite terms comes out to a finite number, is actually equal to pi squared over 6. Which is clearly a finite number. But let's see what happens if we use integral test. Remember, integral test can tell us whether a series converges or diverges if our function that goes along with this satisfies those three criteria. If we just trust me for a moment when I say that that was going to be true about our function here, which is 1 over x squared. But if we go ahead and perform integral test on this, introducing a constant c or a c in the limit, using the antiderivative power rule, we get that this is minus 1 over x. We evaluate that at 1 and c. And this comes out to the limit as c goes to infinity. Plugging in the integration bounds, a minus 1 over c minus a minus 1. And in the limit, we see that the term with the c, well, 1 over an infinitely large number, that is going towards 0. So this whole improper integral is actually equal to 1. So because of this, using the integral test on 1 over n squared, we could say that the series converges because improper integral converges. But we see something else. The value of that improper integral came out to 1. Now Euler, as long as you believe my history, found that that sum of the series is pi squared over 6. Clearly 1 is not equal to pi squared over 6. So all the integral test can tell us is whether or not something converges or something diverges. In the event the series converges, it doesn't tell us what the series actually converges to. So this is a new idea that we're starting to see in math. We're able to prove something about the behavior of these infinite series without actually knowing the true value of what these infinite series are. It's like saying, hey, you know what? I can prove that you have a finite number of Pokemon cards, but I can't prove whether that number is 500 or 200 using the integral test. I can just tell you that number is finite.